Friends, so today this is the first formal lecture in this course on petroleum refining engineering, and no discussion on petroleum refining can happen unless and until we learn what is petroleum. So, in this module, which is module one, you will actually learn what is crude oil, its composition, what are the various hydrocarbons which are present in crude oil, and what is the significance of these hydrocarbons? How are they useful to us and how they are not useful to us? Both ways. And then impurities and their effect on crude oil. And this is something which is very important for us in the refining industry to understand what are the impurities. And we'll get into very great detail in this as we go along in the course. And I'll introduce some definitions. I will not hurry up the discussion, and I will also leave something like 10 minutes at the end for you to ask questions, because I want you to have this is not very tough to understand. This is basic organic chemistry, which you must have studied in your colleges and schools. So there's nothing difficult about this. Now, coming to the barrel of a crude oil, as you know, one US barrel contains 42 gallons and roughly about 159 liters. And this barrel of crude oil, the way it is processed in a refinery, we actually get our products which are useful to us. And what is shown here are products like, I'll just use my pointer. So, products like diesel, jet fuel, gasoline, LPG, and fuel oil, which is used as a fuel not only in the refinery but other industries as well. And you get other distillates also like kerosene and basically petrochemical feedstocks like naphtha, etc. So this barrel is actually holds everything that you and I use on a daily basis, whether it is petrochemicals, whether it is fuel, what we discussed earlier. And if you look at all these products that come out of a crude oil, they actually vary not only in terms of their boiling point, but also in terms of their carbon number and molecular weight. Are you able to see the slides? I forgot to ask you.
Yes, sir.
Yes, sir.
Just interrupt me if you are not able to see the slide, or you're not able to hear me, or not able to see me. Okay. Now, the lightest hydrocarbons which actually we use, I'm talking only about the hydrocarbons which we use, is LPG, which comes off crude oil. And this LPG, which stands for liquefied petroleum gas, is actually a mixture of C3, C4 hydrocarbons, that is propane, butane. And the boiling point is very low, and these boiling points are given at atmospheric pressure. Then comes the major next cut, which is called gasoline, which we in our day-to-day life we call petrol. And the material that you actually put in your car or in your scooter to run your scooter and car is actually boiling in the range of something like 65 degrees or 55 degrees Celsius. IBP stands for initial boiling point, to 215 degrees Celsius. And the carbon range of components present in gasoline ranges from C5 to C11. Molecular weight around 100, 110. Then comes the jet fuel, which is similar to kerosene, and that boils in the range of 193 to 270, in that range, where it has carbon number going from C11 to C18, and 160 to 190 is the molecular weight. Then comes diesel, which is used in heavy duty engines, trucks, buses, etc. That is actually boiling in the range of 271 to 343 at atmospheric pressure, and the carbon range is C15 to C20. This carbon range are only indicative, that can vary actually couple of carbon number lower or couple of carbon number higher. And the molecular weight is 168 to 245. What cannot another distillate that we actually withdraw is called atmospheric gas oil, which is very similar to diesel, but sometimes it is not blended in diesel. It can be actually sent to another process unit for cracking or something. So that temperature is 343 to 427, C20 to C25, and C20 is the molecular weight. And what cannot actually boil off is what is called as atmospheric residue. This is something that will not boil at atmospheric pressure. And if you actually start heating it up above 360, 370 degrees Celsius, then hydrocarbons tend to crack. I'll repeat. Even this atmospheric gas oil, although it is called atmospheric gas oil, but it is distilled out under vacuum so that the distillation temperatures are low. So basically, atmospheric residue is something that cannot distill, cannot boil at atmospheric pressure, because if you try to heat it up above 360, it will crack. It will not boil, and it will crack to some olefins or some other hydrocarbons. So this is something that we have to then put into a vacuum unit, a distillation column operating under vacuum, so that the temperatures are low and we can still distill out further distillates called vacuum gas oil. VGO stands for vacuum gas oil, and that is in the boiling range 427 to 538. Sometimes it can even go to 560 degrees also, 565, and then carbon number C28 to C40. And the molecular weight is way high, something like between 320 to 430. And what cannot even distill, even under vacuum, and vacuum is pretty high vacuum. We are talking about atmosphere, pressure of about 10 millimeter mercury. That means 750 millimeter vacuum. Even at that even at that such a low pressure, there is material which cannot still vaporize, and that is called as a vacuum residue, which is 558 plus. And this is really, really very, very viscous material. It is, if you cool it, it actually solidifies at room temperature. And this is the material which is used to actually make road bitumen. So the roads on which you drive, the black material that you see is actually bitumen, which is made out of this vacuum residue. And then, of course, you have pet coke, which is actually generated once you use destructive distillation of vacuum residue. So from vacuum residue, you can make pet coke also, which is almost like coal, but very low ash. It has very high calorific value. So it is only carbon and hydrogen, kind of a complex structure. So this is actually, the various products that you saw in the barrel, their carbon number, their boiling range, and molecular weight. So next, when you drive into a petrol station to fill up your car, you will know if you're actually using diesel, if your vehicle is diesel driven, you'll know what kind of material that you're buying, in terms of boiling point, carbon range, and molecular weight. This is the typical flow sheet of a refinery. This is not all refineries have this kind of a configuration, but I thought, and I'm not going to discuss this in detail because by the time we end this course, you will know this particular flow sheet by heart. So we are not going to talk much about this flow sheet. Only I was going to tell you that these products that we distill out, these products, they actually are distilled out in a combination of atmospheric and vacuum distillation towers. So you take the crude oil in the atmospheric distillation column and you take out all these products like light naphtha, heavy naphtha, etc., etc. And what cannot be distilled, that is the atmospheric residue, what you saw here, atmospheric residue, is actually goes into a vacuum distillation tower where we actually operate at 10 millimeter G absolute pressure, and you get further products like light vacuum gas oil and heavy vacuum gas oil. And these are actually then cracked in secondary processing units like either a hydrocracker or actually an FCC unit, etc. And then from there you get many other products, including gasoline, diesel, etc. So it's a pretty complex flow sheet, and this is, but believe me, this is one of the simplest ones. In fact, if you look at the configuration of Reliance refinery in Jamnagar, that is, five times more complicated than this. And we will discuss this actually as we go along, but I just wanted to give you an idea in case there's a curiosity as to where these things come from the crude oil. Now, getting into what is crude oil, actually, it is basically called as petroleum. Petroleum consists of two words, petro and oleum. Petro actually comes from the Greek word, basically, it means rock, and oleum is from Latin, which means oil. So basically, it's a rock oil, and the name comes because actually it was found in the rock formations where actually you have sedimentary rocks. And actually, I mean, you have a holding capacity of that oil. Crude oil is a naturally occurring product. It is not synthetically made, it's a naturally occurring product produced over millions of years because of decomposition of organic matter coming either from trees or from animals. And it can be brown to black liquid when you see it in room temperature with viscosity, which is varying all the way from something like water viscosity to even semi-solid uh, crude oil. So I have seen crude oil which are even solid. Okay. It depends upon what kind of composition that crude oil has, and we'll talk about that in greater detail. It actually consists a very large number of hydrocarbons. It's a complex mixture of hydrocarbons of various molecular weights and of various molecular types also. And because of this complex nature, it is called crude oil. And as such, the crude oil cannot be used because it doesn't have those kinds of properties which we need for either running a vehicle or for using it as a fuel. Now, regardless of their origin, all crude oil mainly consists of hydrocarbons. Okay, so it is carbon and hydrogen and its combination. So that's why actually crude oil has its very deep roots in organic chemistry. Okay, so petroleum refining, petrochemicals is all about applied organic chemistry. In other words, industrial chemistry originating from organic chemistry. And in addition to carbon and hydrogen elements, we also have other species like sulfur, nitrogen, and oxygen compounds. And these are what we call as impurities. And also, in many cases, you might even have metals. And the metals actually present in crude oil are generally vanadium, nickel, and iron. So these are the three metals which we find in almost every crude oil. So please note it down. It is not written in the slide. Three metals: vanadium, nickel, and iron. The quantity which is higher is vanadium and nickel. And these metals actually are found more in the heavier products, like the ones that come out here, like atmospheric bottom or in the light vacuum gas oil or actually in the vacuum residue. So you will not find metals in the lighter products like gas or light naphtha, kerosene, diesel. So by definition, these metals actually, and I'll tell you how and why actually these metals are found in heavier boiling compounds. The composition of crude oil, uh, particularly in terms of not only the hydrocarbon types which are present, but also actually in terms of various impurities which are present, does vary very, very appreciably across the world, depending upon where you're buying the crude oil from. And we'll get into detail about that. But more importantly, which I wanted to mention is that even from the same well or what we call as a reservoir, the crude oil composition or its quality can vary appreciably. Like for example, in our own country, we have a huge crude oil reserve. I mean, it's not huge in that sense, but from an Indian sense, it's one of the largest. That is Bombay High. I remember I mentioned it in my last lecture that 300 kilometers west of Mumbai is right in the middle of the sea, is what is called as Bombay High, where they discovered crude oil below the ocean bed. And so they drilled that oil, and that well, those there's several wells there, more than I think 18 or 20 wells, and each one of those wells have been producing crude oil since 70s and 80s. So it's almost like 40 years that we have been producing crude oil from Bombay High, and even that crude oil has changed from the time when it was what it was in 70s and 80s to what it is now. And as I mentioned before, crude oil as such is unsuitable for direct use because of the impurities, more importantly impurities, but also actually the complex nature of these hydrocarbons. And if you look at from an elemental level, yes, just roughly the carbon percentage in crude oil varies between about 84 to 86%, hydrogen between 11 to 14%. So this two put together constitute what is crude oil. In addition to that, you have sulfur. Now, sulfur is one of the major impurities in crude oil, and this is something that we refiners uh, actually are very focused on to be able to remove sulfur from crude oil. And I'll talk about it in greater detail later, but I think it is most appropriate to mention right now that if you look at the quality of gasoline or diesel, when I say gasoline, it is petrol. So in our terminology, we don't use the word petrol, we use the word gasoline, which we use in the vehicles. And this gasoline and diesel quality, if you really look at in our own country, it has actually gone through a huge revolution in a way. I still remember when I was in Delhi with Engineers India Limited. I mean, there was absolutely very little specification on gasoline and diesel. In fact, actually, there was no specification on diesel excepting the boiling range. In gasoline, there was some specification in terms of octane number, and that's about it. And then later on, because of all kinds of reasons, and in fact, we even added lead in our gasoline to improve the octane. So we had leaded gasoline sold till about 1995. Can you believe that? And then, in one fine day, the Supreme Court, passed an order that the oil companies should actually sell lead-free gasoline in the next 5 years. So by year 2000, the country went completely lead-free on gasoline. Lead was added to improve the octane. Okay. And this is something which the world took almost like 20-25 years to go from leaded gasoline to lead-free gasoline. We did it in 5 years. And then from no specification on diesel to today, we are actually the diesel that you buy in a petrol pump is actually Bharat Stage 6 diesel, that is equivalent to Euro 6 quality, which has less than 10 ppm sulfur. So sulfur is something which is very important, and as we go along, you'll hear more and more about how do we remove sulfur for what reason. Then nitrogen is another impurity. Generally, it is found in heavier fractions and in mostly in California and South American crudes, etc. Oxygen is another one which is, of course, not present in that quantity as sulfur, but nonetheless, we do have some oxygenates present in crude oil, and oxygenates in the form of carboxylic acid actually is something which is not desirable because it does corrosion in the refinery and affects carbon steel metallurgy in the plant. And of course, metals. Metals is very low and mostly present in the heavier fraction. So this is a typical composition of crude oil. In addition to that, crude oil actually, if you take crude oil, which is a liquid actually at room temperature, if you look at the crude oil, it actually consists of three phases. You have gases which are dissolved in crude oil, like methane, ethane, propane, and butane. So when you heat crude oil, these gases come out, but they are actually present in the crude oil in a dissolved state. And then, of course, the middle fraction, that is, the gasoline, diesel, etc., which is liquid. And then the bitumen part, which is actually solid at room temperature, that is the short residue and so on and so forth. But actually, it is dissolved in the crude oil. So actually, crude oil has all these three dissolved in each other. And so basically, when you produce crude oil from under the ground, there's a pretty high pressure below the ground, and actually you don't need a pump. Actually, the crude oil comes out by its own pressure, and when it comes out, it has a very large amount of dissolved gases, so they come out, and that becomes that is predominantly methane, ethane, propane, butane type, and they are actually then recovered. Like for example, Hazira in Gujarat near Surat is a place where ONGC has a very large facility where they actually recover the associated gas from Bombay High. So what they earlier actually this gas was being flared at Bombay High in the platforms itself. The gas which actually gets liberated when the crude oil comes out of the ground. So if you remember last time I mentioned that when the crude oil comes out from the ground, you have to actually put it into what is called as a three-phase separator, where you separate out oil, you separate out water, which is actually the bottom layer. Above that is the oil and then the gas. So earlier they were flaring that gas, and now actually that gas is brought through a submarine pipeline, which is actually laid on the ocean bed to Hazira. And that gas is actually the starting point of the Hazira Jagdishpur HBJ pipeline. So Hazira Bijaypur Jagdishpur pipeline, which actually is operated by GAIL, if you remember I mentioned last time. So because the pressure is lower at the surface than the underground, so this gas comes out, and in our country, that is the major source of natural gas, which is not enough, of course. So we do buy natural gas in the form of LNG, liquefied natural gas. But the gas that actually is produced at Hazira is actually the associated gas. So this particular paragraph is very important, at least from an Indian context, and in many other countries like Qatar. Qatar actually also, thrives on this gas, which is actually coming along with the crude oil. So this is associated gas. Now coming on to more of the chemistry side of crude oil, the hydrocarbons, if you recall, I had mentioned it as carbon and hydrogen. So the hydrocarbons which are present in crude oil, they are actually by general formula of CnH2n plus Z. I'm sure you still remember this from your high school chemistry. So any hydrocarbon has a general formula of CnH2n plus Z, where N can vary from 1 to whatever, 60, 100. And Z actually depends upon what the value of Z is. You can have either paraffin. So if Z is 2, that is CnH2n plus 2, then it is a paraffin. Same thing with isoparaffin. If it is CnH2n, then it is naphthene, which is actually a cyclic paraffin. And then aromatics is CnH2n minus 6, which is something like benzene, toluene, or xylene. So this is actually a general formula, and as far as the carbon to hydrogen ratio is concerned, it actually increases, as you know. So the more you go from paraffins to aromatics, so you go from CnH2n plus 2 to CnH2n minus 6. So the carbon to hydrogen ratio increases, or hydrogen to carbon ratio decreases. And similarly, actually, as you actually do more and more alkyl substitution, either on naphthenes or aromatics, that means suppose you have toluene or xylene, etc., then actually you have more hydrogen because those are CH2. any alkyl group is a CH2. So basically, the carbon to hydrogen ratio decreases as you go to a higher homologous series. Now, this is what I've been mentioning. Classes of hydrocarbons, you have alkanes, and all these components are present in crude oil. Otherwise, I won't have been talking about it. This is not a general class on chemistry. So this actually discussion is in context with crude oil. So please understand. I mean, don't think that I've started a class on organic chemistry here. So all these hydrocarbons are present in crude oil, like normal alkanes, normal paraffins with ZS plus 2, and isoalkanes, which is nothing but isoparaffins, which is branch chain paraffins, so like isobutane or isopentane, etc. So this is Z, the same value of Z. Naphthalene is a cycloparaffins like cyclopentane, cyclohexane, methyl cyclohexane, things like that. So there actually Z can be 0 or it can be -2 if two naphthalene rings are fused together. We'll talk about that in a more detail later on. And then aromatics. So if it is Z-6, it is alkyl aromatics like benzene, toluene, xylene, etc., C9 aromatics. But if it is -8, -10, then you are actually getting into two-ring aromatics like naphthalene or three-ring aromatics like chrysenes, etc. So coming on to paraffins to begin with, this is the most simplest molecule that you can think of, which is present in the crude oil. And you have all the way from ethane to propane to butane, pentane, hexane, all these molecules are present in crude oil and even beyond. I mean, I have only listed up to tridecane, but it can go even up to C40, C50. And the boiling range, as you go up on carbon number, the boiling range goes up. So initially it is in the gas form like ethane, propane, butane. And then once actually we have pentane, then it becomes liquid. And as you go beyond 250, 260 degrees Celsius, it is like a solid. Okay, so you have paraffins, and these are all normal paraffins. Okay, what is the significance of these normal paraffins? Actually, normal paraffins, I mean, these components are important in the crude oil. And this particular slide shows you where and how we use these components. Like, for example, oxidation of C8 to C30 normal paraffins results in fatty acids which are used in the soap industry. Then oxidation of C12 to C14 normal paraffins results in secondary alcohols. We have monochloroparafins. This is chlorinated paraffins, which are used as cutting oil additives, also as plasticizers for plasticizing PVC, polyvinyl chloride. So the PVC chappals and many other products that you see in the market, PVC is a hard plastic. It cannot be used as such. So you need plasticizers for that. So monochloroparafins are very important as a plasticizer. Then a very important product that you and I use on a daily basis is a detergent. And today, actually, there is I mean, for the last 30 years, there has been a great emphasis to have detergents which are biodegradable. And with the invention of a washing machine, that becomes more important because a large amount of spent detergent actually lands up in the sewage. So it should be biodegradable and normal paraffin. So linear alkyl benzene, LAB stands for linear alkyl benzene. So linear alkyl benzene around the world is produced from normal paraffins in the range of C9 to C13. And this is separated out from kerosene, C9 to C13 normal paraffins. And we then actually dehydrogenate these normal paraffins to make olefins and then alkylate that with benzene to make linear alkyl benzene. And then, of course, we sulfonate and then neutralize. So basically, the detergent, the active matter in the detergent that you use, which actually does the cleaning function, is a molecule called sodium linear alkyl benzene sulfonate. Okay. So, and then beyond that, when you go for a higher carbon number going to beyond 30 to 35, you land up in a paraffin bag. So basically, the mombatti, the candles that we use during Diwali or during any festival or during any worshipping or any other purpose during birthdays, etc. This paraffin wax, 100% of the paraffin wax, which is actually used to make candles, comes from crude oil. Okay, so paraffin, and this is all normal paraffin in the carbon range C35 and high. Then, what are the negative aspects of these paraffins? This is how we actually, the world uses paraffins present in the crude oil. What is the negative impact is that jet fuel, if it has too much of normal paraffins, its freezing point goes up. And since actually airplanes fly at 40,000 feet, maximum 42,000 feet, the air temperature at that height is minus 45, minus 46, sometimes even minus 48 degrees Celsius. So actually the jet fuel, which is actually filled in the wings of a plane, if you ever wondered as to uh, where does the airplane carries the jet fuel, it is actually filled in the wings, in both the wings. So actually, the wings actually cut the air at 850, 900 kilometers an hour, and that is the reason why we don't want the jet fuel to freeze there. So jet fuel freezing point specification is something like minus 52, minus 57 degrees Celsius, so that it doesn't freeze at that height. But if you have normal paraffins, it will freeze. It also affects, the freezing of diesel in the vehicles in our country. During winter, we have diesel, what we call as a pour point or freezing point of plus 6 degrees Celsius, and in the summer plus 12. But if suppose you have very cold day, the diesel can freeze in the tank. So you may have seen some drivers actually using logwood to actually create fire and then melt the diesel in the diesel tank on board a truck. And of course, lubricating oils that we use in our engines, that freezing point is also because of the normal paraffins. And the ignition quality of it actually improves the ignition quality of diesel fuel, but it affects that of gasoline because gasoline driven vehicles are actually spark ignited, and the diesel vehicles are actually pressure ignited. So the ignition characteristic, the way you ignite these fuels in a closed chamber, in a cylinder, is different. Gasoline is spark ignited, while diesel is pressure ignited. So basically, the ignition quality improves in diesel if you have more paraffins, but it deteriorates in gasoline because it reduces the octane. Coming on to isoparaffins, which is actually a branched paraffin, like formula remains the same, but it is isobutane, isopentane, where actually you have a backbone and one of the carbon actually has a CH2 on it. And all these hydrocarbons actually are based on the quadrivalency of carbon, as you know. You already know that carbon has a valency of 4. So all these hydrocarbons are made with, in all various structures are there in order to satisfy the quadrivalency of 4 of carbon. The basically the there are various kinds of branching. It could be a single branching like 2-methyl alkane, or it could be 2 or 3 branching like 2,3,4 trimethyl pentane and things like that. So generally, you will find that in native crude oil coming from the ground, the double and the triple branching is generally present in the higher boiling fractions. What is the significance of isoparaffins? Friends, isoparaffin is very, very important in our refining industry. In fact, if you would have seen the introduction to my course, there is a complete session on the isomerization of C5, C6 hydrocarbons. Now, actually, the isomerization is important. Isoparaffins have a high octane number, and that's why it is a preferred paraffin in gasoline. Normal paraffins do not have a high octane number, but branch paraffins have an high octane number. And actually, if you look at jet fuel, here again, if you have isoparaffins, the melting point goes down. There is actually something for you to remember between paraffins and isoparaffins. There are two major differences between paraffin and isoparaffin for the same carbon number. So suppose if I take normal butane or I take isobutane. Isobutane means, let's say you talk about 2-methyl pentane. 2-methyl pentane is also butane, but it is isobutane. Now, if you compare normal butane with 2-methyl pentane, then 2-methyl propane, then actually normal butane will have actually a higher boiling point as compared to isopentane, 2-methyl propane. Any isoparaffin for the same carbon number has not only a lower boiling point as compared to normal paraffin, but it also has a lower melting point. So actually, that is the reason in the C9, C13 carbon range, which is the ETF carbon range, you prefer isoparaffins because it reduces the melting point of jet fuel. Same thing in the lubricating oil, because lube oil are actually in the carbon range of C, almost like C, it is beyond diesel. So it is looking at C25 to C40 carbon range. So in that carbon range, there's a tendency to solidify. So that tendency can be reduced by actually putting more isoparaffin. So the oil which you put in the engine is liquid, primarily because it is very rich in isoparaffins. And but such highly branched isomers are undesirable in diesel fuel because the ignition is due to high pressure, and because of that, some very small molecules get formed, and that actually doesn't give you the power that you need in a diesel engine. Coming on to naphthalene, which is again a saturated hydrocarbon. It is the general formula is CnH2n minus CnH2n. But again, this is a very general formula where Rn is the number of naphthenic rings. Uh, hydrocarbons like cyclopentane, cyclohexane, which are actually cyclic nature, but without any double bond. So imagine a ring. I can't draw this here, but imagine a benzene ring with no double bonds here. So that is actually cyclohexane. Around 50% is of the crude oil is naphthenes. Actually, naphthenes are present in a very rich way in crude oil. And generally, if you look at the quantity of naphthenes go up as you go up on boiling point. They are present in naphtha and predominated in most of the gas oils and lubricating oils. Actually, if you look at the lube oil that you put in your vehicle, that is actually very rich in naphthenes. It is also sometimes called as a naphthenic oil. So it has got isoparaffins and it has got aromatics, naphthenes, but very little aromatics, 0.3% aromatics. And we'll discuss that in great detail as we go through. I don't want to actually get into the discussion right now in terms of what is the property of lubricating oil which you use in your vehicle. And that is, but right now, in order for us to complete this discussion, basically lubricating oils are oils which consist of C25 to C40 carbon range molecules, but predominantly naphthalene and isoparaffins. And chemically, these are very highly stable hydrocarbons. So you have several types of naphthenes. The easiest, of course, is the single ring naphthene, which is like cyclopentane or cyclohexane. But then you can have two rings together as well. So if two rings are separated by an alkyl group, for example, so it's like a pendant, two naphthene groups with a long carbon chain in between. And then this is more paraffinic than naphthenic, but that is one kind of naphthene that you find in crude oil. And the other is conjugated ring, where actually the rings are linked with each other. So like decalin, the decalin is actually two naphthalene rings together. Okay, naphthalene. So if you take naphthalene and you hydrogenate it, you get tetrahydronaphthalene, which is actually decalin, which is two ring naphthenes fused together. And if you have more than two, then actually you get multiple condensed rings, and these are generally present in heavier hydrocarbon range, particularly in short residue or even in vacuum gas oil. Coming on to aromatics, this is very important from our perspective. Aromatics actually is forms one pillar of petrochemicals, and the other pillar is olefins. Okay, so it's very important to know what kind of aromatics are present in crude oil, because A, it can be bad news, or B, it can be good news, particularly if you want to make aromatics out of crude oil. So these are unsaturated cyclic hydrocarbons, as you know, with the general formula of CnH2 and minus 6. Depending upon the crude oil, the aromatic content can vary from anywhere 8 to 10% to even 16%. Like most of the crude oils that we produce in India, whether it is Bombay High or Assam, they are rich in aromatics. So we actually do produce crude oils which are very, very rich in aromatics, both Bombay High and Assam crude. And these aromatics are present in the entire range, whether it is gasoline range or whether it is jet fuel range or diesel range. So you will find a higher amount of aromatics present if it is coming from Bombay High or Assam crude. And also, actually, you could have polynuclear aromatics, like for example, anthracene or higher homologues. They are pretty chemically reactive, and it is something that the refining industry likes. For example, the entire polyester that is produced in the world actually comes from aromatics. So you take paraxylene and you oxidize the paraxylene to make purified terephthalic acid, and then you actually do condensation polymerization with monoethylene glycol ester, and then you polymerize that to make polyester. So and polyester, as you know, is used in PET bottles. It is used in garments, and in fact, it has actually helped to actually reduce the consumption of cotton to a very large extent, and be able to actually give affordable clothing to poor people. So this is something I gave this example just to create a curiosity in your mind that aromatics is important. Not only paraxylene but also metaxylene, orthoxylene, as well as benzene, toluene, etc. And these are actually the various types of hydrocarbons. We talked about alkyl aromatics so far: benzene, toluene, xylene. You can have naphthalenes, the naphthalene balls that you use to get rid of moth and other insects when you actually store away your woolen clothes or in the cupboard or actually in the toilet is actually these naphthalene, which is separated out from the kerosene fraction of crude oil itself. So naphthalene also, actually the naphthalene balls that you use is actually also coming from crude oil. And these are two fused ring of benzene together, that is naphthalene. And if you have more than two, like three ring fused together, you could have side by side, which is chrysene, or it could be one above the other, like phenanthrene, and so on and so forth. So as you go up, go higher and higher and higher, or you get into the vacuum gas oil area, or even beyond that into short residue, you'll have multiple ring aromatics. More like if you really get very heavy, you get almost like a honeycomb type of a structure of aromatics. In addition to having two fused ring of benzene, there is also aromatics which are present with the naphthene ring along with the aromatic ring. So that is actually something like your and indane. So indanes are hydrocarbons where you have benzene ring with a side ring fused together of cycloparaffin. And this is this is actually what I should say. What we call as indane, and these are generally present in the kerosene range hydrocarbons. If you have actually two ring, that is an aromatic ring fused along with a cyclohexane. So if it is pentane, then actually it is indane. If it is cyclohexane fused along with a benzene ring, it is called tetralane. So these are the two nomenclatures you can find in the literature, indanes and tetralane. And these are in fact, what I'll do also, actually, I do have this textbook. So this material which I am covering from the textbook, Jenna, I will email it to you, this textbook, because I don't know whether some of you have dug it out from the internet, these books. But if you haven't, I will actually email you this textbook and you can then circulate it around. And I'll email further textbooks. This is part one, part two, part three, part four, part five. So as I go along, I will actually keep on emailing further parts to you. So all this what I'm covering here is actually already written in those books. So the one problem with aromatics is that they are carcinogenic. So benzene is a known carcinogen. It creates cancer. And that is why actually around the world and in our own country, we have tried to limit the concentration of benzene in gasoline. In mid 90s, actually it was welcome because it actually improved the octane. But then, people added lead also. So the health effects of lead were discovered, the negative effect of lead addition, and so lead was phased out. And then, in order to, so when lead phased out, the octane came down. So, in order to go up on the octane, they put benzene. And then, then the world woke up that benzene is also carcinogenic. So then there was a move to reduce the benzene content. So earlier it was 8%, then came to 5%, then down to 3%, and today it is less than 1%. In fact, some countries in the world like US and Korea and Japan, they have even reduced the benzene level in their gasoline to less than 0.6%. So in India, we have less than 1% benzene in the gasoline. So this is something that you should remember. Talking about octane, this is very important in today's context because you cannot sell gasoline unless it is an octane number of 92. Currently, there's a talk to even go up to 95. So current specification is 9092. If you look at the various types of hydrocarbons that we discussed, that is paraffins, isoparaffins, naphthalene, and aromatics, and normal paraffins by far are the least desirable because actually it creates knocking in the engine and they have very low octane number, something like 70, 72. Isoparaffins and naphthenes have relatively higher octane, but still not high enough. Okay. As compared to normal paraffins. But if you have triple branching, like 2, 3, 4, the trimethyl pentane, which is called isooctane, that actually has an octane number of 100. So that is the third bullet here. So if the octane number of isoparaffin increases as the degree of branching of the chain is increased. So if you have, let's say, 2,2-dimethyl propane or 2,2-dimethyl pentane, and that is because at number two position there is double branching. So there is only one single carbon sitting there. And But on the other hand, the olefins have very high octane number. So they, of course, one thing that you would have noticed is that. Can you just hold on? There's a call coming through. Just a moment. Hello. Yes. Yes, Kuldeep. Tell me. I'm fine. Hmm. नहीं अभी तक तो नहीं मिला. I've been waiting for it. Oh yeah. Okay. Mm-hmm. Mm-hmm. Okay. All right. Yeah. 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 Sure. Mm. Yeah. Sorry about that. Can you see the slide and hear me? Hello.
Yes,
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 sir.
sir. Yes, sir.
Yes, sir.
Okay. So olefins do have a very high, octane number, but actually native petroleum, the way it is dug out from the ground, doesn't have any olefins. It has the reason why it has no olefins is that olefins is a very reactive molecule, and it will react and it will get saturated to paraffin, or it will cyclize to make naphthenes, etc. So in petroleum, the way it is actually dug out from the ground, if you analyze that crude oil, it has zero olefins. But actually, in our industry, we do crack some of these streams, and then we produce olefins, etc. And so actually, we add those olefins in the gasoline to improve the octane. And you'll see as we go along, and as we discuss the other secondary processing units, I will tell you more about it. And of course, the highest octane number is those of aromatics, and that's why actually we kept on adding benzene and aromatics, etc. So today, if you look at Euro 6 specification on gasoline, which is called Bharat Stage 6, it has a limit on benzene. It has also limit on total aromatics. Like you cannot go beyond 35% aromatic, and so on and so forth. So there's a limit on aromatic because of carcinogenity, but nonetheless, we need aromatics in order to improve the octane of gasoline. And these are some of the numbers that you see. For example, if you look at normal heptane, it is zero. Then, as you go up in terms of branching, this is like 2,3 dimethyl pentane, it is 42. As you go up to methylhexane, it is 91. If you look at toluene, it is 120. And methyl cyclohexane is 75. 4,4-dimethyl 2-pentene. So this is not only an olefin but double branching at the second position of the carbon. 1,1-dimethyl cyclopentane. So this is actually a naphthene with a double branching here. So these are and actually the reference is 2,3,4 dimethyl 2 to 4 trimethyl pentane. So that 2 to 4 trimethyl pentane is the reference, which is called isooctane, and the octane number of that molecule is 100. Okay. Uh, Coming on to the impurities which are present in the crude oil. There are, of course, crude oil, the way it is obtained in the refinery, it has water, it has free water. So the water has to be drained out. It is also some sediments which are present. That means sand and some siliceous material, etc. So that is called basic sediment and water. You also have salt present in crude oil, actually, because of the salt which is present in water. And also because the way crude oil is transported around the world. Actually, when you fill up the crude oil in a ship in the Middle East and then transport that to India, let's say, and it actually empties out in India, then the compartments which are present in the ship in which the crude oil is filled, they become empty, right? And the ship can lose its balance on high seas. So actually, the ship actually fills up seawater in those compartments so that it has its stability, which is called ballast water. So after emptying out the crude oil, it takes our seawater, the seawater in our shore, and it sails back to Middle East. Now there actually it empties out the water and fills up crude oil. So that is how actually the salt gets into the crude oil, and also the water gets into the crude oil, as also the water which is associated with the crude oil in the well itself. Sulfur, of course, sulfur, nitrogen, metals we already talked about. It also has oxygenates which actually result in acid. The electrolytes, inorganic gases like CO2, H2S, etc., and this debris. So BSNW actually stands for basic sediment and water. And there are so many. So these are like sediments or sandy material can be actually separated out in the tank. It actually precipitates out. The water also precipitates out. But again, actually, the crude oil is very heavy crude oil, having higher density. Then sometimes this water is very difficult to separate. It forms a kind of a sludge. So, but overall, these are the major impurities which are present. Again, the metals are actually nickel, vanadium, and iron. Okay. These heteroatom compounds containing nitrogen as a constituent are known as heterohydrocarbons. So basically, amongst the impurities, if you look at sulfur, nitrogen, and oxygen, they are not present as free elements. Okay, they are always present in form of a hydrocarbon. And so these are actually called as heterohydrocarbons because you have a molecule which is other than carbon and hydrogen, which is present there. So we come to the first discussion of sulfur compounds. Sulfur compounds, as I told you, is very important. We need to get rid of it. And sulfur is present in hydrocarbons in various forms, in various types. In crude oil, it can vary from 0.1 to even 8%. And generally, just to give you the perspective, the crude oil that we use in our country, like the crude oil that is, produced at Bombay High or Assam crude, these are low sulfur crudes. Fortunately, we are blessed with low sulfur crudes. But then if you buy crude oils, let's say from Middle East, let's say from Saudi Arabia, etc., some of those crude oils can be high sulfur. So this is what I mentioned here. Indian crudes are, this definition of sweet I will introduce later. But overall, actually, just to give you a kind of, just to give you an idea, crude oils which are actually low in sulfur are called sweet crudes, and crude oils which are high in sulfur are called sour crudes. Okay, so this is a distinction between sweet and sour. And the non-hydrocarbon type sulfur, which is called as inorganic sulfur. So you have sulfur compounds present both in organic and inorganic form. The inorganic sulfur is mostly in the form of H2S. I don't see much of elemental sulfur, but generally in the form of H2S and carbonyl sulfide. So these are like dissolved in the crude oil. So H2S is definitely there because the kind of smell that you actually smell in a refinery when you actually enter the refinery is that of H2S, and that is actually stripped out of crude oil and then recovered, and then actually you make sulfur out of it. The sulfur is present in all these forms actually in the organic sulfur. So the inorganic sulfur is mostly in the form of hydrogen sulfide, but the organic sulfur actually comes in various types of hydrocarbons. For example, the mercaptans, which is present in almost entire range of hydrocarbons, all the way from LPG to even like diesel range. In fact, those of you who have actually used LPG at home, all of us have used LPG at home. Actually, the smell that you get of LPG, if you actually leave the burner open without getting it lighted, that smell is because of mercaptans. So that is R stands for the alkyl group. So this could be methyl, it could be ethyl, it could be propyl. Generally, the mercaptan that we use in LPG is ethyl mercaptan. So we actually dope something like 5 to 10 ppm of mercaptans in LPG in order to create that smell, so that you know if suppose you have not lighted the burner that you do have LPG coming out. Otherwise, LPG by itself has no smell, and that can be dangerous because you may leave the burner on without getting it lighted, and it might fill the whole house. And then somebody switches on electricity, and with that spark, the whole house can catch fire. So that is why we add mercaptans in LPG in order to create that pungent smell. So you can imagine the very pungent smell that you have or because of mercaptans. And this is also these mercaptans are also very corrosive, and they actually corrode the carbon steel metallurgy in the refinery. You have thiophenes as well. These are actually cyclic sulfur compounds, like 5 ring membered structure or 6 ring membered structure, but instead of carbon, you have sulfur there. Okay, so these are thiophenic sulfur, and this is what we call a cyclic sulfur. And then you have sulfides like RSR, which is dimethyl sulfide or methyl ethyl sulfide, or even a disulfide, which is the dimethyl disulfide. So you have actually, and then of course in the combination with oxygen, you could have sulfoxides and sulfones, etc. So you have various types of sulfur compounds, and actually what happens is that as you go up on carbon number, the sulfur species also keep on changing, or their percentage. So for lighter hydrocarbons like C3, C4, generally the dominant sulfur species is mercaptans. But as you go to gasoline, you have mercaptans plus actually you start getting thiophenes as well. Then you have things like benzothiophene, where a thiophene that is a 5 membered ring structure along with a benzene ring. So it is called benzothiophene. That would actually be also present in gasoline. The moment you get into kerosene or diesel range compound, predominantly in diesel range, the sulfur present is in the form of dibenzothiophene, where you have two benzene ring along with a thiophene. Or you can even have alkylated like 2,4-dimethyl dibenzothiophene, etc. And these disulfides, etc., or sulfides, they actually are present in almost the entire range of hydrocarbons. So these are to be removed. So if you discuss each one of them, H2S, highly toxic, and it has got a very distinct odor, as you know. It is like a rotten egg, present in but this is generally present in the lightest hydrocarbon, generally in LPG. And we have to remove it from LPG, otherwise it can be very corrosive. It's a weak, because it's a weak mineral acid, and it can actually create corrosion in the carbon steel, which is used to construct the refinery plants. Mercaptans, which is also called thiol, is acidic, and it also actually, and as you know, it is a very disagreeable odor. So this is also creates corrosion. So this has to be removed for sure, and we'll understand how these things are done. later on in the course. Sulfides and disulfides are relatively unstable and easily converted back to mercaptans by heating them. Thiophene is very difficult and generally you need hydrodesulfurization. So actually you treat this with hydrogen where hydrogen reacts with sulfur to make H2S and that's how you can actually remove thiophenes. So there are various refinery technologies which have actually developed and deployed to get rid of sulfur, whether it is mercaptans, whether it is sulfides, or whether it is thiophenes. And also, actually, it is not only important for us to reduce sulfur in the fuels that we use, but also actually sulfur in various streams which are actually treated using a catalyst, because some of the catalyst can be poisoned with sulfur. So actually, as you'll see that when we discuss technologies like catalytic reforming or isomerization or even stream methane reforming, we do remove sulfur in the stream to less than 1 ppm. Otherwise, that sulfur can affect the catalyst. So as you see, actually, there is these are the sulfur compounds and their boiling range, just to actually give you an idea what kind of thiols which are present here. What is the effect of sulfur compound in crude oil? We have discussed it quite a bit of detail. They're actually corrosive in nature. They can actually create, it can actually lead to gum formation during storage. It does create pollution, as you know. So, in good old days in mid 90s, etc., even in year 2000, the specification was 2000 ppm sulfur. When you actually burn these fuels in your vehicles, in your internal combustion engine, the sulfur gets combusted to sulfur dioxide, and that comes out through the tailpipe, and that actually pollutes the atmosphere because it can lead to acid rain, etc. So that is why we have limited the sulfur down to less than 10 ppm. It actually has all kinds of problems in the vehicle itself. It causes wear in engines. And as I mentioned, we have to remove it in the refinery because it acts as a poison in some of these technologies. Coming on to the oxygen compounds are also present in crude oil, but relatively low as compared to sulfur. Sometimes even as low as 0.2%, 0.3%, maximum to 8%. But generally, their concentration increases as you go to the higher boiling range. You don't find them much in the gasoline and the kerosene range hydrocarbons. Generally, these oxygen compounds are present in the form of phenols or furans, where furan is actually a five-membered ring structure with an oxygen instead of carbon, and you have two benzene rings on the side, or in form of naphthenic acid, which is actually a carboxylic acid, which can cause corrosion, and esters. So you have various kinds of oxygenated hydrocarbons. Generally, we don't like these oxygenated hydrocarbons present in the final fuel oil, and these are removed. And generally, we use hydrogen to react with this oxygen so that it forms water and takes it out. The effect of oxygen compounds, the major effect is because of the naphthenic acids, which is actually a carboxylic acid of a long, which is attached to a long alkyl chain. And these naphthenic acids actually either an alkyl change or a naphthene ring. And these acids create corrosion. So it is because of the carboxylic acid. So these are something that we have to deal with. We can't remove it while you're doing crude distillation. So we add corrosion inhibitors, etc., and monitor the corrosion. Coming on to the nitrogen compounds, they are also, as I told you, present in some crude oil, not all, but also actually more and more present as you go up on the molecular weight. And all oxygen and nitrogen is much lower than sulfur. And so you have both kinds of nitrogen compounds, basic as well as non-basic. And generally, the kind of nitrogen compounds present are amines, amides, pyridine, and carbazole is again something which is a five-membered ring along with two benzene rings with a nitrogen instead of carbon, and so on and so forth. So these are both basic nitrogen like amine, quinoline, isoquinoline, and non-basic nitrogen like pyrrole, indole, etc. Okay, so these are the kind of nitrogen compounds, and they also get removed once you go through a hydrogen treating step of each of these, any of these streams. So they actually form ammonia when they react with hydrogen, and that's how we actually remove these nitrogen compounds. The high molecular weight nitrogen and sulfur compounds, which are actually present mostly in asphaltenes, which is the heaviest end of the crude barrel. So these are complex structure known as porphyrins, which are generally present in asphaltenes, which is actually the building raw material for making your road asphalt. So these are like asphaltene molecules or sheets comprising of condensed aromatic rings, and these condensed aromatic rings contain sulfur and nitrogen in them. We don't really have to discuss this much because this is something that we don't actually upgrade to anything useful. They ultimately land up either in the fuel oil or they are used to make bitumen of the roads. So, in perspective, this is actually how it stacks up. This picture is very good in the way that you can see the boiling point goes going from -100 to +600, and the carbon range from 1 to 50. And this is where actually the LPG is, and then the naphtha or gasoline. These are this is the so this is a graph which you can study in your own time. Then this is jet fuel. So as you can see that your carbon number higher, the boiling point is also higher. Then your diesel fuel, and then of course the waxes and this is the lubricating oil range. We are talking about C25 to C40 carbon range, and then the asphalt, which I was just talking about a minute ago, the asphalt is. This is really high in terms of carbon number. So these are my final few slides, couple of slides. So the application of major crude fractions for value addition, we get one of the major products in a refinery called naphtha, which from which we make gasoline, but also actually this is feedstock for making petrochemicals in a naphtha cracker. So we put this naphtha into a cracker at very high temperature along with steam, and that actually gives us olefins like ethylene, propylene, etc. We also make food grade hexane out of it. This slide is just to give you a perspective as to what petrochemicals, major petrochemicals that we actually manufacture from which stream. So far, I've only discussed fuel, but this actually talks about petrochemicals. So naphtha is actually the starting feedstock. Naphtha again is the boiling material from 65 to 210, so in that range. And this is also the feedstock to make food grade hexane, which is used for recovering vegetable oil from seeds, from vegetable oil seeds. It is also used to produce pure chemicals like pentane, hexane, octane, etc., and various special boiling point solvents which are used in the paint industry. The kerosene range hydrocarbons, I already told you about C9 to C13 or C10 to C14 carbon range normal paraffins, which is actually the starting raw material to make LAB, used in detergents, and then naphthalene to make naphthalene. Gas oil or diesel range hydrocarbons, the normal paraffins are used to make synthetic fatty acids and higher alcohols. The vacuum gas oil, other than actually being cracked to produce further valuable products, it can also be used directly to make lube oils and also to make wax. In fact, back in IAP, when I was at IAP, we actually developed and commercialized a wax making technology at Numaligarh refinery. So that particular unit, which was set up at a cost of 800 crores, produces paraffin wax and microcrystalline wax from Assam crude. Assam crude is quite waxy in nature. So it has aromatics, it is rich in aromatics, it is rich in wax also. And that's why actually there's a good potential to make wax from Assam crude. So we got two units operating in Assam, one in Digboi refinery and the other at Numaligarh, which makes paraffin wax from crude oil. And this is one technology which I developed and commercialized there in Numaligarh. And then, of course, when you deep distill, going beyond 610, 620, you can actually get additional quantities for secondary conversion or microcrystalline wax. So that's about it. And actually, these are some of the definitions which I will actually introduce in the next class, and then we will continue from there. Okay. I think some of you already know, but I think I will introduce these definitions in the next class on Friday, and we will continue.